Hello students, welcome to my channel Positron. Dear students, today's topic is a equipotential surface. This is very important topic in terms of JEE NEET or even in CBSE board exams. In every board exam you can say. Equipotential surface, equipotential surface is a surface at every point of which potential is constant is called equipotential surface. Equipotential surface is a surface at every point of which potential is constant called equipotential surface. Let it is a charge Q. Suppose this is a charge Q. Now, many concentric spheres you can draw around the charge. Many infinite concentric spheres you can draw about this charge. Let it is a positive charge Q, right? Then V is equal to 1 upon 4 pi epsilon naught Q over R. Potential at a point is V is equal to 1 upon 4 pi epsilon naught Q over R. Within a sphere, at each and every point, right? On this circle, at each and every point, potential will be 1 upon 4 pi epsilon naught Q upon R. It means at this every point, potential will be constant, right? But I'm not saying that the potential at this and this surface will be constant. At different spheres, potential will be different, and if it is a positive charge, V is equal to 1 upon 4 pi epsilon naught Q upon R. It means V is proportional to 1 by R. If R increases, radii increases, then potential decreases. As you move away from the center, continuously potential decreases, means this has the potential, yet potential of this sphere at every point of its surface is a constant. Potential of this sphere at every point of the surface, it is constant, but less than the potential of this sphere, right? So as you move ahead, potential at every sphere decreases, right? Now look here, what I have said, V is proportional to 1 by R. If you will move ahead, then the potential will continuously decrease. So it is an equipotential surface. If you draw the field lines, because it's a positive charge, so field line begin the positive charge and goes towards infinite. Now look here, dear student, if you draw the field lines, these field lines will cut normally to this equipotential surface. It means field lines always intersect normally to the equipotential surface, right? Look here again, I have said that potential at each point of the surface of the sphere, V is equal to 1 upon 4 pi epsilon naught Q by R, right? And V is equal to W upon Q, or W is equal to Q into V. Dear student, look here, if at this any point, any 2 points considered on the same equipotential surface, are on the same sphere, then these 2 points has the equal potential, means potential difference is 0. So if V is equal to 0, so no work is done in moving a charge over that sphere. If you want to move a charge Q, if a question is asked that it is a equipotential surface, and if you want to move a charge from here to here on the surface of same sphere, then the work done would be 0. Why? Because the potential difference between any 2 points will be 0. Now dear student, due to point charge, the equipotential surface will be how? It is a concentric sphere. Due to a point charge, the equipotential surface will be concentric spheres. Now let's move further. Let's talk about the different equipotential surfaces. Let field lines are coming from too far, right? Let the field lines are coming from too far. In this way, the field lines are coming in this way, right? If they are coming from too far, then the field lines will be parallel, and if they are equidistant, it means the field line is a uniform, right? Dear student, if the field lines are parallel, it means they are coming from too far, and if they are equidistant, it means they are coming from too far and they are uniform, means creating uniform electric field. Now, like field lines are coming to us mind, right? The equidistant parallel field lines are coming to mind, that the equipotential surface will be a plane like this, right? Look here. Look here. Any plane in the way of field line will be equipotential surface, and look here. This field line will intersect it normally, right? The field line incidenting on this surface will intersect it normally. What I have told you initially, that a field line intersects normally to the equipotential surface. So look here. Now, dear student, field line here will be like this. The plane, a plane perpendicular to the field lines, will represent in this case equipotential surface. If the field line is moving in this way, then you know it is at higher potential than this, right? The potential will decrease in the direction of field line, just I have said. If it is a charge q, right, then many concentric spheres around this charge are the example of equipotential surface. You know V is equal to 1 upon 4 pi epsilon naught q by r. At this, let it is r1, this one is r2, and r1 is less than r2. So it has a higher potential than this as you will move ahead, and you know the field line begin from positive charge and end at infinite. Now in this direction, look here, the potential decreases in the direction of field line. Now dear student, in the case of point charge, concentric spheres are the examples of equipotential surface. In the case of parallel field line, a plane perpendicular to the field line is the example of equipotential surface. If the charge is distributed, if the charge is distributed, or I'm talking over a wire, or I'm talking about the line charge. Line charge is this. Look here. This is a line charge. A thin wire. Here is a thin wire on which charge is distributed, either positive or negative, no matters. Now, dear student, if the charge is uniformly distributed over the thin wire, then now look here. If it is a thin wire, the field line will emerge in all the directions. So, around this thin wire, right, you can imagine a hypothetical cylinder of radius small r, length is small l. Any hypothetical cylinder of any radial length above the wire will be the example of equipotential surface. In this case, these are the points of equipotential because lying at an equal distance from this thin wire, right? So every every point on the surface of the cylinder will represent the the cylindrical surface about the thin wire is the example of equipotential surface. Now any 2 point you consider over the surface of the cylinder, potential will be same, so the potential difference would be 0. So no charge, no work is done, and no work is required in bringing the charge or in moving a charge from one point to other point on the equipotential surface. Why? Because W is equal to Q into V. If you consider the equipotential surface, then what happens? In the case of equipotential surface, 2 point has a equal potential, so the V is here, not the potential, it is just the potential difference. So potential difference would be 0, so work done would be 0. Dear students, let's move further. Relation between electric field and potential difference in case of equipotential surfaces. Dear students, what we have to do? We have to find out the relation between electric field and potential difference. How you can, I mean to say that how electric field can be derived from the potential, right? Very simple. Let two equipotential surfaces be considered, and they are del L distance away. This has the potential at each point V, and this has the potential. Each point is it has V plus del V, and it has V, right? You can say, or you can say it is V, then it has V minus del V, right? Now, dear student, this is the direction of the field. The two equipotential surfaces that we have considered, this surface has potential V at each point of it, and this surface has a potential V minus del V at each point of it, and these two are separated by a distance del L, right? And this is the direction of electric field. In the direction of electric field, potential decreases, right? Here, drop in potential is in the direction of field. How? Here at each point, these two are the different equipotential surfaces. At every point of this equipotential surface, potential is V, whereas at every point of this equipotential surface, the potential is V minus del V. Now, E is equal to V upon D, right? Or V is equal to E into D. This is the relation between the potential difference and electric field. Now, dear student, the potential difference between these two will be how? This is V final potential minus initial potential, and that is equal to E into del L, right? Or this is minus del V is equal to E into del L, or minus del V is equal to E del L, you can write, because E and del L are in the same direction. It's a cos 0, A dot B is equal to AB cos theta, or A cos 0 is a 1. So E is equal to minus del V upon del L. Now, dear student, this is the relation between electric field and potential difference. E is equal to minus del V upon del L. But the dear student, you find the relation between electric field and potential difference considering the two equipotential surfaces on which the potential on one of the surface each point has the potential V, on an other equipotential surface each point has the potential is V minus del V. So we find the potential difference between them, and you know E is equal to V upon D, V is equal to E into D. So potential difference was I put equal to E dot dl. E and dl are in same direction. A dot b is equal to ab cos theta. It turns out to be cos 0 becomes 1. E is equal to minus del b upon del. Important is not this. The important in terms of if you are aspirant for the JEE and NEET, then this is not important. Most important is it is E is equal to minus del V upon del L. This is also said E is equal to minus grad V, right? E is equal to minus grad V. Dear student, what result we get from this? The main result what we get from these all discussions, that electric field line intersect normally to the equipotential surface. The first conclusion that we get, that electric field line intersects normally to the equipotential surface. And second one is the direction of electric field will be the electric field will be directed in a direction where the change drop in potential is steepest or sharpest, right? So the first conclusion that we have got is that the first conclusion what we have got from the equipotential surface is that the electric field line intersect normally to the equipotential surface, and the second conclusion what we have got, that the electric field line will be directed in a direction, the direction of electric field will be such that the drop in potential will be sharpest, steepest, maximum, right? The electric field will be directed towards the sharpest or fastest, steepest, maximum change, maximum drop in the potential, right? The maximum drop of potential will represent the direction of electric field. Now, dear student, this E is equal to minus del V upon del L also can be written as E is equal to minus grad V. Means electric field can be represented as a negative gradient of potential. Gradient is similar operator. You can write like this. E is equal to minus del V, right? Sometimes this is going to be useful for you. Or E is equal to minus del is what? I cap del by del x plus j cap del by del y plus k cap del by del z V. And now you can operate over this. This is a gradient operator. In this way, you derive the electric field from the potential. Dear student, potential is a scalar quantity, but the field is a vector quantity. Now, gradient is an operator that is applied over a scalar and result into a vector, right? Electric field is a vector quantity and potential is a scalar quantity. When this operator is applied over a scalar, you get a vector. In this way, potential and field are related to each other. If the potential is given, then you can find the value of field, right? We might be given as a x square minus 2x like this, then you can find out del v over del x. Del v over del x equal to 2x minus 2. Now, in similar way, we might be given in terms of y and z also, and then you have to find out the field at x equal at 0.012. Then you can replace the value of x in del v over del x, x equals to 0, and similarly del v upon del y you will find, del v upon del z you will find, and you will replace here the value of del v upon del x, del v upon del y, del v upon del z, and ultimately you will find out, you will replace the value of x, y, z are the point at which you have to find out the field. And then once if you got, this is going to be really, this is going to be, if vector E is equal to, if once you are able to find out vector E is equal to Exi cap plus Eyj cap plus Ezk cap, then you can find out vector E is equal, mod of vector E is equal to under root Ex square plus Ey square plus Ez square, right? So let's move further. The next topic is dear student, next topic is that is equipotential energy. Or EPE, EPE, electric potential energy, right? EPE, electric potential energy. If you are a JEE or NEET aspirant, this is a very important topic going to be for you, because in many cases it is asked that the three charges are kept at the vertices of a triangle, then what would be the electric potential energy, or what energy required to assemble them, right? Dear students, let EPE in a system of two charges. EPE in a system of two charges. Let the two charges are Q1 and Q2, and their distance is small are apart, and we have to find out the EPE, electric potential energy. You are very familiar, you are a student of 12th standard, I am very sure, and you are very familiar that all the energy in this world are scalar, right? So no need the vector representation here. Now dear students, the first very simple case I have considered, it is system of two charges Q1 and Q2. They are smaller distance apart. We have to find out the EPE, electric potential energy of this system. How we will find? If you are, these are the two charges Q1 and Q2 kept our distance apart. If you are able to find out the potential due to this charge at this point, and then you can say that this Q2 charge is brought from infinity to this point. Let it is a point A, this is a point B. If you once give the name to the point, the things becomes very easy. Now potential at point B due to Q1, potential at B due to Q1, what will be? Let it is V1, that is equal to 1 upon 4 pi epsilon naught Q1 by R, right? Now you got the potential. So work done in bringing this Q2 charge at a point where the potential is this. Now the question is that what will be the work done in bringing the charge Q2 from infinity to a point B where the potential is this. And W is equal to V into Q. V is already you have got 1 upon 4 pi epsilon naught Q by R, Q1 by R, and now this Q2 charge is brought. So this is the electric potential energy. The work done in bringing these two charges, in assembling these two charges Q1, Q2 at a distance small r away. This is the EPE, electric potential energy. U is equal, W is equal to 1 upon 4 pi epsilon naught Q1, Q2 by R, right? Now, dear student, here what I have done, I have find out first the potential at point B, this charge Q1, and then applied that what would be the work done required to bring the charge Q2 at point B in a potential due to Q1. Inverse you can say, you can solve like this. Let's find out the potential at point A due to charge Q2, that is again 1 upon 4 pi epsilon naught Q2 by R. And now the work done in bringing this Q1 charge from infinity to point A, and that is W is equal to V into Q1. So in both the cases the same answer you have got. Whether you find first the potential due to Q1 at point Q2 or potential due to Q2 at point Q1, and now replace W is equal to V into Q. In this way you will be able to find out the electric potential energy of system of two charges. Now let's move further. What would be the EPE, electric potential energy of system of three charges? System of three charges. Dear student, let the three charges are Q1, Q2, Q3. That is, they are R1, R2, they are R1, R2, R3 distance apart. Right? The distance, this odd triangle, every edge is different. Now, the three charges Q1, Q2, Q3 are kept at the vertices of triangle, and the distance, the edges of this triangle are R1, R2 and R3. We have to find out the EPE of the system, electric potential energy of the system. How will you find out? Dear student, what I am doing, this time when there is more than three or more charges, then what you have to do? You have to bring one by one, right? First I am bringing Q1 charge. This is a point A, this is point B, this is point C. First I am bringing charge Q1 at point A. When you are bringing charge Q1, other charges were absent, so here the potential is 0, so work done is 0. W is equal to V into Q1. In the absence of any other charge, here the potential difference would be 0, so its work done is also 0, that is W1 equals to 0. Now I am bringing Q2 charge. Now bringing charge Q2. Now first charge Q1 is brought. Now charge Q2 is brought. What happens? If you bring Q2, then Q1 is already present. So you have to first find out the potential due to Q1 at point B. So W2 is equal to potential at B into which charge is brought. This charge is brought here, that is Q2, and potential will be Y due to Q1, because Q1 is present. Now you didn't have brought the Q3. So due to Q1, here the potential will be 1 upon 4 pi epsilon naught Q1 upon R1 and Q2 you bring. So this is the W2, right? Now dear student, let Q3 is brought. When you are bringing the Q3, Q1 and Q2 are already present. Now first you have to find out the potential as C due to Q1 and Q2, and then W is equal to V into Q. Q is Q3, you will apply. Dear student, always remember potential is a scalar quantity. You have to, in order to find out the potential due to different charges, due to system of charges at a point, you have to apply the algebraic sum. But keeping in mind, due to positive charge, potential would be positive. Due to negative charge, potential would be negative. Now dear student, at point C, this W3, no, at point C, no, W3, work done in bringing Q3. First, we have to find out the potential at C, because before Q3, Q1 and Q2 already you have dropped. So, potential at C due to Q1 is 1 upon, due to positive charge, potential is positive. If it would have been negative minus Q1, then the potential would have been here minus 1 upon 4 pi epsilon naught Q1 upon R2. So, but here is positive. So, potential due to Q1 at point C is a 1 upon 4 pi epsilon naught Q1 upon R2, and due to this one, 1 upon 4 pi epsilon naught Q2 upon R3. This is the V, and charge is brought Q3. This charge is brought here. So you have got 1 upon 4 pi epsilon naught Q1 Q3 over R2 plus 1 upon 4 pi epsilon naught Q2 Q3 upon R3. In this way, dear student, the EPE of the system becomes W1 plus W2 plus W3 like this. W1 is 0, W2 is this much 1 upon 4 pi epsilon naught Q1 Q2 by R1 plus this much is a 1 upon 4 pi epsilon naught Q2 Q3 by R3 plus 1 upon 4 pi epsilon naught Q1 Q3 upon R2, not R square, is R2. In this way, dear student, we find out the EPE of the system. Means EPE is what? The work done, the energy required to assembling a charge. Right? Now, I'm moving ahead. Dear student, let this is a square, right? This is a square. This time a different problem I am considering. Let it say plus Q, minus Q, and this is minus Q, this is plus Q. Each side of is a. Now, what we have to do? Let these points are A, B, C, D. We have to find out the EPE of the system, right? Electric potential energy of the system. Dear student, first, in order I'm bringing the charge. First I'm bringing charge on A, then charge on point B, then charge on point C, then charge on point D. And the same technique I'm going to apply and we'll find out the EPE, electric potential energy of the system. Now, when you bring charge plus Q at point A, at that time, no charge was, we are bringing the charges in order one by one. So first I am bringing the charge Q, other charges at that time were absent, so the W1 is equal to 0 simply. Now I am bringing charge plus Q at point B. In this case, W2 is equal to V into Q, and V at this point, because this charge already, this is the first to come, so the potential at this point, due to this charge is a 1 upon 4 pi epsilon naught Q by A into Q, that is Q square upon A. This is W2. Now let's find W3. At this point, this is a potential into minus Q. These two charges already you brought, right? These two charges already you brought. Now we have to find out the potential at this point due to these two charges. Now consider this distance, this is R, this is A, so this is A root 2. Now dear student, first we'll find out the potential at this point, then multiply by minus Q. So potential at this point due to this charge, it is 1 upon 4 pi epsilon naught Q upon A root 2, right? 1 upon 4 pi epsilon naught Q upon R. And due to this positive charge, potential at this point again would be positive. It is 1 upon 4 pi epsilon naught Q by A into minus Q. Or it will be minus 1 up, both the results should be minus. This is Q square by A root 2 minus 1 upon 4 pi epsilon naught Q square by A, right? And now W4. Potential at point D. Now these three charges already we brought. Now potential at point D will be, we will find out the potential at D due to this and due to this, and then we will take the summation of that. Now W4, due to this, potential at this point will be 1 upon 4 pi epsilon naught Q by A. Due to this, at this point, plus 1 upon 4 pi epsilon naught Q by this distance, that is A root 2. And potential at point D due to this, again this is a minus charge, negative charge, potential would be negative, minus 1 upon 4 pi epsilon naught Q upon A. In multiplied by the charge you are bringing here, this is minus Q. W is equal to, dear student, what I had done, W is equal to V into Q. V, due to all these three charges, I found out the potential at point D, and because you are bringing the charge minus Q multiplied by minus Q, so that's W4 is equal to V minus Q. Now it becomes, look here, this would be cancelled, so it is, you are left with minus 1 upon 4 pi epsilon naught Q square by A root 2. Now EPE of the system, EPE of the system, U is equal to W1 plus W2 plus W3 plus W4. Simply you have to consider the algebraic sum. W1 is 0, W2 is 1 upon 4 pi epsilon naught Q square over A plus W3. W3 is a what? Minus 1 upon 4 pi epsilon naught minus 1 upon 4 pi epsilon naught Q square upon Q square by A root 2 minus 1 upon 4 pi epsilon naught Q square by A, and then W4 is a minus 1 upon 4 pi epsilon naught Q square by again A root 2. Now dear student, U becomes what? Look here, I'm removing all these, erasing all that. Now look here, these two are the same terms and these two are the, look here, these are positive, that this is negative. I'm very sure that you can, this can, my board can appear in camera. Yeah, right. Now look here, this is positive, this is negative, similar. Now cancel it. So you have got minus 1 upon 4 pi epsilon naught to Q square over A root 2. Or you might write U is equal to minus 1 upon 4 pi epsilon naught. This root 2 would be cancelled, Q square root 2 by A. This is the answer. This is the electric potential energy of the four charges kept at the vertices of a square having each as small a. In this way, we find out the EPE of the system. Dear students, I tried my best to let you understand whatever the topic is going on the whiteboard, and it's least but not last, it's my humble request to you all that if you think that my way of teaching is going to be fruitful to you, then please like, share and subscribe. Must put bell icon over my videos so that you might be notified about my next video. Till then, very goodbye to you all. Thank you. Meet you in next video very soon.